Imagine a world where your private conversations, financial transactions, and personal data are open for everyone to see. Unsettling, isn't it? This is where cryptography comes in. Cryptography is the knight in shining armor of the digital realm, protecting your privacy and ensuring your security in an increasingly connected world. It's the invisible wall that shields your personal information from prying eyes, the secret handshake that confirms your identity, and the ironclad lock that keeps cybercriminals at bay. When you're texting a friend, making an online purchase, or logging into your email, cryptography is hard at work. It scrambles your data into an unreadable format, only to be decoded by the intended recipient. It's like sending a letter in a secret language, one that only you and your friend understand. In essence, cryptography is the bedrock of trust in the digital world, enabling secure communication and transactions over the internet. Without cryptography, the digital world as we know it would be a playground for cybercriminals. So, what exactly is cryptography? In simple terms, it's like a secret language. Imagine having a personal diary you don't want anyone else to read. Cryptography would be like writing your entries in a code only you can understand. In the digital world, it's a method of protecting information by transforming it into an unreadable format. This transformation process isn't random, but uses carefully crafted algorithms. Think of these as complex recipes that dictate exactly how to scramble the information. But there's another key ingredient, the keys. These keys are secret values that the algorithm uses to make the transformation unique and secure. Cryptography isn't just about making things unreadable, it's also about being able to read them again. With the right key, the scrambled information can be unscrambled, returning it to its original form. Cryptography is the art of writing or solving codes, a crucial tool in safeguarding our digital lives. There are several types of cryptography, but we're going to focus on the three main ones: symmetric, asymmetric, and hash functions. Let's start with symmetric cryptography. Imagine you have a secret message and you want to send it to your friend. You put it in a box and lock it with a key. Now you send the box to your friend, but they can't open it unless they have the exact same key. That's how symmetric cryptography works. The same key is used for both encrypting and decrypting the data. It's like a secret handshake between you and your friend. The strength lies in its simplicity and speed. However, the challenge is safely sharing the key between the sender and the receiver. Next, we have asymmetric cryptography. This type involves two different keys, a public key for encryption and a private key for decryption. Think of it as a mailbox. Anyone can put letters or data in your mailbox, encrypt data with your public key, but only you have the key to open it and read the letters. Decrypt the data with your private key. This resolves the key distribution problem of symmetric cryptography, but the trade-off is that it's slower due to the complex mathematical processes involved. Lastly, we move to hash functions. These are a bit different. Instead of encrypting and decrypting data, hash functions transform the input data into a fixed-size string of characters, regardless of the input size. It's like making a unique digital fingerprint of your data. The beauty of hash functions is that even a tiny change in the input creates a drastically different output, making them ideal for data integrity checks. To sum up, symmetric cryptography is like a secret handshake. Asymmetric cryptography is like a locked mailbox, and hash functions create a unique digital fingerprint of your data. Each type has its strengths and weaknesses, but all play a vital role in securing our digital world. Cryptography isn't just for secret agents. It's used every day in things like online shopping, banking, and even sending emails. Let's start with online transactions. Every time you swipe your credit card or click purchase on your favorite e-commerce site, cryptography is there, protecting your financial information. Secure Socket Layer, or SSL, is a cryptographic protocol that provides a secure channel between two machines operating over the internet or an internal network. This means that the information you send over this channel is scrambled in such a way that only the intended recipient can understand it, keeping your data safe from prying eyes. Then there's password storage. We all know the importance of a strong, unique password for every online account. But what happens if the website you're using gets hacked? That's where cryptography comes in. Techniques such as hashing and salting are used to obscure your password. Even if a hacker gets their hands on the hashed version without the original salt or key, it's practically impossible to reverse engineer your password. Next, let's talk about digital signatures. Have you ever wondered how you can be sure an email really came from your bank and not some scammer trying to steal your information? That's where digital signatures come in. When a bank sends you an email, they'll often include a digital signature. This is a piece of data that can only be created using their private key, which is essentially their cryptographic identity. By checking this signature with the bank's public key, your email client can verify that the email really did come from your bank. Finally, let's not forget about virtual private networks, or VPNs. These use cryptography to create a secure tunnel for your internet traffic, protecting your data even when you're using a public Wi-Fi network. Cryptography is everywhere, working behind the scenes to keep your digital life secure. Cryptography might seem complex, but it's fundamental to our digital security. In this video, we've covered the immense value cryptography holds in our cyber-secured world. It's the backbone of safeguarding our digital transactions, protecting our personal information, and ensuring the integrity of our communications. We've delved into the essence of cryptography, that it's the science of encoding and decoding information to prevent unauthorized access. We've explored its three main types: symmetric, asymmetric, and hash functions, each with its own strengths, weaknesses, and ideal use cases. Symmetric cryptography is like a secret handshake. Asymmetric is akin to a locked mailbox, and hash functions are one-way streets. Lastly, we've looked at the everyday applications of cryptography. It's in our online shopping, our emails, even our phone calls. It's the invisible guardian that keeps our digital lives secure. Remember, without cryptography, there's no security. And without security, there's no trust in our digital world.